Okay, this time we want to look at the idea of pure substances and mixtures, the difference between pure substances and the two types of mixtures, and then also how we go about separating those mixtures if we want to do that in the lab or any other circumstance. Mixtures are the physical combination of two or more pure substances. So we take two substances, compounds, elements, and we mix them together. It can be at least two, sometimes more than two. This is a physical change, so the separation of mixtures will also be physical changes. So we're not actually changing the composition of any of the components, we are just either mixing them together or separating them. Depending on what we're mixing, the concentration of the various things, the composition will be different. There are two major types of mixtures. The first type is what is known as a homogeneous mixture. A homogeneous mixture is a mixture that is the same all the way through, evenly distributed throughout the container. So each component of the mixture is evenly distributed. One example of this might be salt water. Salt water, the individual particles of sodium and chlorine that make up the sodium chloride or salt, are evenly distributed throughout the mixture of the salt water. The more concentration of salt that you have in there, the more individual ions of sodium and chloride that will be found, but they are equally distributed all the way through. Another way to think of this might be Kool-Aid. If you had Kool-Aid, you don't think of it having, concentration where there's a lot of sugar in one part but not in the other. If it's evenly mixed all the way through, it would be a homogeneous mixture. Tap water is a homogeneous mixture. Tap water contains the water molecules, H2O, but also contains other minerals, things like fluoride, and other components that are found in our water, and they make a homogeneous mixture. A muddy lake or something like that is a case where it's not a homogeneous mixture, where you actually have a heterogeneous mixture. Heterogeneous mixtures are the other type of mixture that we deal with. These are where the mixture is not evenly distributed. Other names for this include suspensions or colloids. Heterogeneous mixtures are mixtures where the items are not equally distributed. Easy example of this one to think about is oil mixed with vinegar for salad dressing. If you take a heterogeneous mixture like salad dressing and leave it sit for a while, it will actually separate into its individual components and start to create different layers. Oil and water mixed together is a heterogeneous mixture. You can really shake it up and try to get it as close to homogeneous as possible, but you'll still have pockets of oil, pockets of water. A couple of good examples of this to also talk about are things like milk. Milk is actually a heterogeneous mixture. If you have fresh milk straight from the cow, it would separate into a layer of cream on the top and a layer of liquid on the bottom. We don't like things to separate that way, and we don't like our food to be separated, so we homogenize our food, and most of the milk you buy in the store is homogenized milk. So it's made to be a heterogeneous or a homogeneous mixture, even though it normally is a heterogeneous mixture. Pure substances are something that has just one composition. It's an individual element or compound. The only way to break apart a pure substance would be through some sort of chemical process. For example, water, pure water is a pure substance, just H2O molecules. Tap water has other things in it and makes a solution or homogeneous mixture in most cases. If you wanted to separate the individual elements of water, one process you could do is electrolysis. You run an electrical current through the water and it separates into hydrogen gas and oxygen gas. But that's a chemical process that's taking place. Separating a mixture is a physical process. The other thing I want to look at is another type of mixture there's to mention here, which is known as an alloy. An alloy is a mixture of two metals. If we think about mixing two metals, one of the most common cases we deal with this is gold. If you look at gold, pure gold, 24 karat gold, is just gold atoms. It's very, very soft. It bends and is very flexible. It doesn't work very well for the most common use of gold, one of the most common uses, which is jewelry. When you buy jewelry, it's generally 18 karat or 14 karat gold. Then you've made a mixture with copper, silver, and gold. Larger concentrations of copper and silver in 14 karat, smaller concentration in 18 karat. That's why 18 karat is more expensive. But by making a mixture, what's known as an alloy, you get something that's stronger and can be better used for jewelry. It's also slightly less expensive. Also, a lot of common alloys that are made from aluminum. A lot of aluminum alloys are used to make the frames of cars, airplanes, things of that sort to be very, very strong compared to just aluminum by itself. When you separate a mixture, it is a physical change. There are three common ways of separating mixtures that we are going to use in the lab: distillation, filtration, and the phase changes of sublimation and deposition. Generally, most of these use the properties of the individual, the physical properties of the individual parts of the mixture to separate that mixture. Starting with distillation. Distillation is where we take a mixture that contains liquids and we heat that mixture. The substance with a lower boiling point will start to boil. As it boils, it will rise up in this tube and be forced down into the condensation tube. Once it hits the condensation tube, there's cool water being run in around this tube. So cool water is being forced around that tube. As it reaches inside that part of the tube, it condenses, forms a liquid again, and that condensation is collected down here in this container. This picture comes from your textbook, so if you want to see a copy of it, it's in your textbook. This would be a good way of separating salt water. The salt will not boil, the water will boil at a much lower temperature, close to 100 degrees Celsius. Salt would be at a much, much higher temperature before it started to boil. So at 100 degrees Celsius, or just barely above 100 degrees Celsius, the water starts to evaporate, and you can collect the pure water over here in the container, leaving the salt behind. If you don't want to worry about collecting the water, you just want to get the salt by itself, you could just evaporate off the water and the salt would be left in the container. Filtration is a good method for separating solids and liquids. You take a filter paper, you pour the mixture into the funnel that has the filter paper in it. The filter paper has small holes, small enough that the liquid can travel through, but the solid cannot. The solid is left behind, and you collect what's known as the filtrate, the liquid below. And a third case that we will look at is where we separate by using sublimation and deposition. If you have a substance that will sublime, go straight from a solid to a gas, for example, iodine. If you heat that iodine, it will form a gas, and then you can collect that iodine by cooling that gas back down, and it'll go back to a solid. So you could use the combination of sublimation and deposition to take one solid that undergoes sublimation at a normal temperature and separate it from another solid. So two types of mixtures, heterogeneous and homogeneous. We also have pure substances, which are individual elements or compounds. They are actually, if it's a compound, it's two or more elements bonded together, not just mixed together. We can separate those mixtures by doing physical changes, such as the distillation process, which uses the physical change of boiling and condensation, the filtering process, which just separates the solid from a liquid, or sublimation and deposition.